Alrighty, IB students, today we are studying topic 1.9, which is binomial theorem. So this falls under the number and algebra topic. And so in your formula packet, we've got two formulas provided to you. The first is an example of what an expanded binomial looks like. The second is a formula for just one term in that binomial expansion. All right, so let's jump right into an example. So the first question is asking us to use the binomial theorem to complete this expansion. Well, you could certainly use this formula, but I just like to use the pattern that happens whenever we expand a binomial. So one of the things we know is going to happen is if this is a power 4, we are going to wind up with 5 terms. So you always have one more term. So I know I am going to have 5 terms here. 1, 2, 3, 4, 5. And they're actually already giving us the first 2, but I'm going to go ahead and actually generate all 5 terms as though they had not given me the first 2, because they might not on your IB question. And what we're going to do is we're going to start by finding the coefficients of each of these terms. And there are several ways that you can find these coefficients. One way you can find it is you can use Pascal's triangle. And so you probably remember this from Algebra 2. To create Pascal's triangle, you sum the two numbers, 1 and 2, to create the number below it. 2 plus 1 is 3. And then 1 plus nothing is 1. So you have a 1 out here. 1 plus 3 is 4. 3 plus, I'm sorry about that. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus nothing is 1. So how far out do you need to go? The second number in actually tells you what it is an expansion of. So this is an expansion of a 4th power. Second number in, that's a 3. This is an expansion of a plus b to the 3. If you needed an expansion of a plus b to the 5th, you would actually create one more row. So that is one way that you could generate your numbers. Another way you can generate your numbers is this first number is going to be NCC0. The second number is NC1. The third number is NC2, NC3, NC4, and the n comes from the power of your binomial. So this one would come from 4C0. This would be 4C1, 4C2, 4C3, 4C4. If we wanted to test one of those, let's just go ahead and find 4C1. Your combination notation can be located in 2 different places. So first place you can find that is your math menu, and you can go over to your probability menu, and you'll see a combination right there on number 3. So you could find it that way. So if we wanted to find 4C1, which means from 4 objects, and how many ways can you select one? Our answer is 4. If you wanted to find 4C2, for example, and 4, if you go back to Pascal's triangle, that marries up with what we had in that row. If I wanted to find 4C2, for example, I'll show you another place. In our secret menus, if you hit your alpha in your window, this is where a lot of the functions that we use frequently are located, and right there, number 8 is your NCR, so that's your combinations. So 4 combination 2, we got 6, and sure enough, 4 combination 2 is 6. So if I'm only going up to maybe 4 or 5, it's really fast to just generate Pascal's triangle. You can do it in less than 30 seconds. But if I'm going any higher than that, I definitely use my calculator. So the 14641 is going to be my coefficients of each of these terms. And then from here, we're going to start with this 3x. And this is what sits in the position of A. So that 3x is a. I'm going to raise that a expression, 3x, to the highest power, to the 4th power. And on your next term, that's going to drop 1 degree. And on your next term, it's going to drop again to 3x squared, 3x to the 1, 3x to the 0, which is 1. And then my second term is going to be this b expression, so the plus 2y. And I'm going to, instead of decreasing my power with each successive term, I'm going to increase my power. So I'm going to start with 2y to the 0, which I'm not going to write because that's equivalent to 1. 2y to the 1, 2y squared, 2y cubed, 2y to the 4th. And now we are going to expand or clean up each of our terms. So please remember, when you have a quantity like 3x to the fourth, you need to keep that in parentheses. Both the x gets raised to the fourth power and the 3 in front. So 3 to the fourth power is going to give us 81, x to the fourth, and that is the first term that they gave us, so that's great. Our next term, you're going to have the 4. You're going to have the 3 cubed, which is 27, and then you also have 2 to the 1. So we're going to multiply 4 times 27 times 2, and we get 216. You still have an x cubed, you still have a y to the 1. And that does match the second term that they gave me. We have a 6 here, 3 squared is 9, 2 squared is 4. So we're going to take 6 times 9 times 4, which gives us 216 again, x squared, y squared. Then we have a 4, we have a 3, and we have 2 to the third power, which is 8. So we're going to do 4 times 3 times 8, which is 96, x to the 1, y cubed. And then on the last one, 2 to the fourth is 16, y to the fourth. So that is our full expansion of this binomial raised to the fourth power. All right, so you're going to possibly be asked two different types of questions. One is where you're expanding out a binomial, or maybe finding a few terms, like the first 3 terms or the last 3 terms, because there is a lot of symmetry. The other type of question you might be asked is to find a very specific term. So question 2 says, find the coefficient of x cubed in the expansion 2 minus x to the 5th power. So I always have students that just want to expand this whole thing out and write all 6 terms. You certainly can do that, but that is taking time. And that might be time you need on some other problems. So I would love for you to be able to solve these problems just by using our formula for a very specific term. So I'm going to start by writing that formula down. So we have NCR. I'm sorry. This is your formula to calculate NCR, my bad. This is your formula to calculate NCR, which is a combination by hand. We'll use the calculator to do it. The formula we're grabbing is this one right here. So it's their example of the expanded binomial, and this is the general form of any term. That's the one we're using, my bad. I circled the wrong one before. So NCR times A to the n minus r times B to the r. So we're going to substitute in what we know. So in this expansion, I know my first term is A, so A is equal to 2. I know my second term is B. If there is a subtraction symbol, then the x includes the subtraction symbol. So B is negative x. And then our exponent is actually n. So n is equal to 5. And I'm going to substitute in what I know. So I know I've got 5CR. I don't know what r is yet. A is 2 to the 5 minus r power. B is negative x to the r power, which I don't know yet. And so you might be looking at this and saying, well, I can't proceed forward from here. There are too many unknowns, which is true, except that they're giving you some other piece of information in the problem. They're telling you that they want you to find the coefficient of the term that has x cubed in it. So this term is eventually going to become x cubed. If this term right here is eventually going to become x cubed, what must r be? R must also be a 3. So just from knowing that this simplifies to x cubed, that tells me that r is equal to 3. And now I can drop in my r value. So 5c3 times 2 to the 5 minus 3 times negative x to the third power. And we're going to calculate what that is. So recall, we're going to find 5c3 here. So I'm going to use, you can type in the 5 first if you want. I'm going to go to my alpha window, and I'm going to choose option 8. So 5c3, and that's going to give us 10. So we're going to have 10 here. This is going to be 2 squared, so that's 4. I have a negative 1 cubed, so that's a negative 1, and then x cubed. So 10 times 4 times negative 1 is negative 40x cubed. Now, this is the term, but they're not asking for the term. They are asking for the coefficient. And if you give the full term, they're not going to give you full credit. So my coefficient of that term is negative 40. Make sure you make your final answer really obvious. Otherwise, they're going to think that you think that this is a coefficient. And that's just a matter of knowing the terminology. Okay, so let's look at one more variation of finding a very specific term. So this is the last one. Determine the constant term in the expansion of x minus 2 over x squared to the 9th power. So I'm looking for a constant term. What is a constant term? Well, when you have an expansion, like 3x squared plus 2x minus 5, we know our constant term is the term that has no variable associated with it. So I'm looking for the term that has no variable. Okay, so I'm going to start by just finding the formula for one specific term. So I'm coming back up here. I'm going to grab this general formula for a term. So NCR times a to the n minus r times b to the r. And let's identify what we know. So we know a is x. We know the b term is negative 2 over x squared, and we know that my power is 9. What I don't know is r. And I'm going to drop in, substitute in what we've got already. So I've got 9cr, my a value is x, to the 9 minus r power. My b value is negative 2 over x squared to the r power. All right, so the question says determine the constant term. So in the previous problem, we had been told that my term had an x cubed. Now, if it's a constant term, it means there isn't an x on it. Or you could think of it this way, it's some term that has an x to the 0, because an x to the 0 is equivalent to 1, and the variable wouldn't be there on my term anymore. So I'm going to clean this up a little bit. Specifically, I see that I have a fraction raised to a power. So this would really be negative 2 to the r power over x squared to the r power, which is x to the 2r power. And so I know that if my variable is going to go away or become 0, when I combine x to the 9 minus r with x to the 2r on the bottom, this is going to eventually become x to the 0. So I'm going to come over here. So x to the 9 minus r times something that has an x over x to the 2r in the denominator. So in other words, an x to the 2r down here, if I were to combine these together. If this is going to become 0, doesn't that mean that these powers need to be identical in order for them to cancel out? Or you could actually subtract them. So you could say, all right, this is x to the 0. I need this to combine together as one variable expression. So when I have a fraction, I subtract. So that would be 9 minus r minus 2r. So that would be x to the 9 minus 3r. And I know that I need to force this to be 0, so I am just going to set that power equal to 0 and solve from there. And we get an r value of 3 would create an x to the 0, which means there would be a variable in that term. So I am going to substitute 3 back into my function. And I'll find out very quickly if I've made a mistake, because my term should not have any variable left in it. So we're going to have 9c3 times x to the 9 minus 3 power times negative 2 to the 3 power over x to the 2 times 3 power. And we're going to clean this up a little bit. So we're going to start by finding 9c3. So 9c3 is 84. Here we're going to have x to the 6th power. I have negative 2 cubed, which is a negative 8. And on the bottom, I have an x to the 6th power. And sure enough, this is what I was hoping would happen. My x to the 6th cancel. I'm just going to come straight through this answer key down here. And I got 84 times negative 8, which gives us our final answer, which is negative 672. And sure enough, we wound up with the term that has no variable in it. Okay, so now you've seen several different examples of binomial theorem questions. Thank you so much for listening, and good luck with topic 1.9.